So my lesson is going to be on an introduction to electronics. I've included a couple of images here of some different circuit boards. Hopefully you've seen something like this at some stage, perhaps if you've opened something up and taken a look inside. So in the top right hand corner you can see all of these different little components, and they all have a specific function and they interact together to do something more complex or useful. Here's a more modern circuit board. You can see the components are quite a lot smaller. And then in the bottom right hand corner we have a modern computer motherboard, which is really the pinnacle of consumer electronic complexity. And I've also included a simple diagram of an atom. You don't really need to take away much from that, other than the fact that there are protons and neutrons and electrons which weigh about 1,000 times less than them, so they're very easy to move around as a result. And it's really the taming of the motion of these electrons that we broadly refer to as electronics, and it has been the cornerstone of modern science and technology for the last 100 odd years or so. So what is electronics? So metals have this interesting property where they form this lattice of protons and a sea of free electrons that can then freely and easily move around this metal, which we often refer to as a conductor. So we can push these electrons along the conductor to do useful things. Two terms that you've probably come across or will come across quite often during the course of this talk are voltage and current. Voltage is essentially the force that moves the electrons through a conductor, and current is the amount of the electrons that flow through a conductor over a given period of time. So really, electronics is the study of the motion of electrons through these conductors and what we call components, which I'll talk a bit about later. So what can electrons do? Well, they can emit electromagnetic radiation, most commonly in the form of visible light. So here we've got some LEDs, but also in all sorts of different display technologies, LCD monitors and so on and so forth. They can also emit invisible forms of electromagnetic radiation, such as radio waves, Wi-Fi signals, 3G, TV broadcasts, that kind of thing, or microwaves for the purpose solely to heat something up. They can also apply forces magnetically and electrostatically. So here we have a motor as an example, and a speaker which has a cone which is driven magnetically, which then applies forces to air molecules to set up pressure waves, which we then perceive as sound. And they can also create heat, which is often an unwanted byproduct of electrons' motion. So these are all outputs. They affect our world with some useful action, but that's not all that electrons can do. They can also measure things, which we could consider to be an input. So in the same way, they can sense electromagnetic radiation. Here's a simple webcam that senses visible electromagnetic radiation. Then they can also sense invisible forms of electromagnetic radiation. So here I have a little infrared image of a house showing different temperatures of different parts of the house, and radio wave antenna set up for TV broadcasts in this case. They can also sense a variety of different inputs in useful ways, so commonly buttons and knobs and things that are very easy to manipulate by people. And just as another example, they can sense sound. Really, there are many more things that electrons can measure from the real world. Almost everything, in fact, that happens in our universe can be measured with electrons. I've put a little asterisk there because there is a caveat, and that is that you have to be close enough to whatever it is that you're trying to measure in order to do so. But that's not all. A lot of the power of electrons comes from the fact that they're really controllable in many useful ways. Also, the things that control them, that we refer to as electronics, are very miniaturizable, and so that means that we can pack a huge amount of complexity into a very small space. And so there's this concept I want to talk a bit about, which is modular complexity or abstraction. and it's a really useful recurring theme that you'll probably see a lot in engineering science, but it's especially applicable to electronics. So I've got a little video here of these things. They're called dominoes. You might have come across them. They're these little rectangular pieces, and you can set them up on their side such that you can tip one over, and then that one will go and hit some more, and it'll set up a chain reaction such that eventually you've got hundreds of these things falling over. And I think this is a very useful analogy to the way that electronics works, in that you can have something like a keyboard which you could then press a button on, and then that sets off a chain of events which does something very, very complicated by calling on different layers of abstraction where there is more and more complexity hidden away. And so you might have a program that then runs as some piece of code, and then your operating system might be this blue layer here that takes in some input from the internet, and then eventually produces some useful output in the form of a monitor or some sound or something like that. And so you can imagine that here this large layer down the bottom represents all of the things that are happening on your motherboard in terms of all the electrons interacting and doing complicated things. But you don't need to know anything about how any of that works to be able to deal with this program layer on the top. Or maybe you're dealing with something a little bit more complicated. You're writing a programming language here. And if you've done any programming, you're probably well aware of the fact that you don't need to know anything about how the electrons behave in the motherboard to be able to do something useful to create a program. And so this concept of abstraction is really powerful, because it allows people to work on different things, and they develop an expertise where someone might be really good at designing motherboards here, but they might not necessarily know so much about writing an operating system. So you've got some experts here that work on writing an operating system, and we've built up all of these successive layers of complexity, and what we end up with is some really complicated device that allows you to do something as simple as press a button and then have some really complicated output occur. And that is really fundamental to the power of electronics.